Hi there, this is Thiru, author of bitbee, and welcomes you to the Java Dev interview series episode number 2. We have received very good response for the first episode which is released last week, and thank you all for that. If you not yet watched that episode, I recommend you to watch it. You can find the link here in the info section or in this video description. Today we'll continue with the left out questions from the last episode, that is on MQs, Kafka and some other important Java Dev interview questions. Before diving to the questions, please subscribe to the channel if you are not yet subscribed, and please share the channel with your friends. Without making any further delay, let's move on to the questions. And the first question is, what is Kafka? In your resume, if you mention that you worked on Kafka or you have experience on Kafka, then definitely you are going to face the questions on this topic. Kafka is a powerful open source distributed platform for handling real-time data streaming. This allows you to publish and subscribe to those streams of records similar to a messaging system. It is very well known for its high throughput, fault tolerance and ability to handle massive amounts of data. Yeah, you might be getting something out of this definition, but interviewer might not be impressed with your answer, right? So the immediate next question from the interviewer is, can you explain a bit more how actually Kafka works and how it handles large pipelines? So to answer these questions, you must have some knowledge on these topics. That is, what is messaging queue and what is the pub/sub architecture. Don't worry, we got you cover everything here. We'll take you through the simple visuals of the messaging queue and the Kafka flow or the architectures so that you will be in a position to answer all those questions. So now let's explore what is messaging queue first. So generally, queue is line of things which are waiting to be handled. If we take an analogy or an example of a toll gate, the vehicles coming are wait in a queue until the toll checker processes their toll fee. Similarly, coming to the messaging queues, technically, these queues will hold the messages or events, or we can say the streams which are coming or produced from one of the service. Then those events will be stored for a certain amount of time or temporarily at the message queue, and then they will be delivered to the respective end service, or we can say the consumer service. Here there also be a communication between the messaging queue and the services. Like service 1 will ask here messaging queue, hey, have you delivered the messages so far I have submitted to you? Then message queue will answer to the service 1 once all the messages were delivered to the service 2 or the end service. And this process of producing and consuming events continue through the messaging queue or the broker asynchronously between the services. This is how the simple messaging queues or MQs will work. Now let's explore the what is pub/sub architecture over the messaging queues. So in a typical microservices architecture, we know there will be a multiple services involved. Hence there will be a number of producer and consumer services, or we can say multiple publishers or subscribers. The message broker sits in the middle of the system and helps multiple services to publish the events and messages centrally to the system, and these messages or events will be delivered to the respective subscribers or end services. And hence here the important thing is the configuration, that is mapping config between the publisher and the respective consumers. I hope now you are in a situation to answer what is messaging queue and what is pub/sub architecture. Now let's see what is the actual architecture of the Kafka and how it works. The reason I'm taking you deep into this topic because there is all relation between these messaging queues, pub/sub architecture and the Kafka flow. So you will be in a situation to answer any of the topics coming onto you. So finally coming to the Kafka, it supports publishing and subscribe to the events and streams. Unlike traditional messaging queues, it can store events as long as you want, and it can also process events when they arrive or on demand. If we take an real world services like web events, stock prices, financial transactions, emails, audits and analytics services, they generate a huge or heavy data in a seconds or minutes, right? And this data has to flow to the end services or end users asynchronously and continuously. So for this kind of heavy and data streaming systems, the traditional messaging queues or pub/sub architecture not fits. And this is where Kafka comes handy. Kafka provides dynamic storage capacity and message broker system inside it. So these data events or streams coming from the systems were placed into the different message brokers based on the topics they categorized. Since these brokers has to store and process the large amount of data, again these brokers were divided into partitions for better performance and horizontal scaling. And coming to the topics, if we take an example of stock price, this data has to continuously broadcast to the audience or the applications using it, right? So this is stock price topic, and the subsystems which are subscribed to this topic, they will continuously get the data or messages from this topic if they are subscribed to that particular topic. Now let's explore what is the typical message or data contents that is flowing to the Kafka. So the data or message going to the Kafka will contains key, value, timestamp, header, partition and offset. So when I say a message or event or record or data, these all are the same for the Kafka. Suppose if we take one example of a user order from an e-commerce system, from the service system it can post the data like cart ID, what is the value and what is the timestamp. There can be a header message from where it is originated, and finally the partition and offset ID, which are important. Partition and offset IDs were added to the message by the Kafka once the message is written to the topic. Usually this data will be formatted in a JSON structure and will be posted to the Kafka. So when a service or application is connected and configured with Kafka, the respective systems also configured with a serialize and deserializers. Before the message was posting or reaching to the topic, the message has to be serialized and converted to the bytes. This is what the serializer does. On the other side, this is same with the deserializer. It converts back the bytes to the original message. So now you can go through the differences which makes Kafka special from the traditional messaging queues. So that is all about the Kafka. I took little time of you for this, but I hope it worked for you. Now let's move into the next question. So moving to the next question, why you are using Kafka in your project, why not other queues, and where you are using it in your project. I hope now you can answer this very easily, right? We use Kafka in our project because of its high throughput, scalability, fault tolerance, real-time processing and integration with other systems. And coming to the next question, what serializer you are using for Kafka? So there were many popular serializers used with Kafka. Usually those are JSON serializer, protobuf serializer, string serializer, byte array serializer, confluent schema registry serializer, thrift serializer and Avro serializer. I have just mentioned the different serializers and use of them. You might also know which are the serializers you are using. For better understanding of each of them, I recommend you to make a little research on them so you will be good with the serializers. Coming to the next question, that is fourth one. Why you are using key? What is the significance of key in Kafka? Yes, you have already heard it in our discussion now, right? You are right. When we discussed about the structure of the message that is going to the topic, there is a key involved in that, right? And this key plays a significance role which is used to determine the partition to which a message will be sent. So the key is used to identify its respective partition. This key also plays a one more important role, that is sequencing the order of the items. In the order you send the messages to the Kafka topic, in the same order they should be delivered to the end system, right? Most of the times it's very crucial. So when you send a same key for the particular set of messages, they should be in a order. They will go to the same partition, hence the order will be preserved for the delivery. So here in the example, you can see if I send the same keys 1, 2, 3, 4 for the several messages, like for one particular order that is prepared, shipped and delivered, then these 3 messages will be stored in the same partition, like you say here P1, partition 1, then they will be delivered to the end system in a same order. Which is very important here, user should not get the delivery message before getting the shipping message, right? On the other side, suppose if you are not sending the same key or there is a null key, then those kind of messages will be stored in a underutilized partitions, or like you can see here, these are orphan or independent messages. I hope now you understood the significance of the key. Let's move to the next question. So this question is again from the Kafka. How is it exactly storing key or getting data using the key? So actually when the message is assigned to a partition based on the hash of the key will determine the partition. We know this, right? So of course consumers can read the messages from the particular partitions using this key only. If the key is same for the set of messages, the consumer can retrieve them efficiently from a particular partition. So this is how key is stored and data will be retrieved. So move on to the next question, and the question is from the REST APIs. Actually this question is about the good practices of the REST API. The HTTP status code 200 indicates a successful request, meaning that the server has successfully processed the request and provided the expected response. And if there is really an error, it is more appropriate to use a status code that reflects the nature of the error. You can see on the screen there are different HTTP status codes or the error codes which are really meant for the errors. So when you send HTTP status code 200 when actually it is not, then this could lead to issues with error handling and make it difficult for clients to distinguish between the successful and failed requests, right? Let's move to the 7th question. The question is, if you don't want to show the actual exceptions but you want to show some valid response to the consumer, how will you mark these types of exceptions? I think mostly you can answer this if you worked with the global exception handler, right? Generally this is the case of throwing custom exceptions. We have to follow 3 steps to achieve this. First one is to create custom exception classes. Then using controller advice, we need to handle the exceptions globally. And the final third step is we need to throw that respective custom exception from the controller or the service class wherever it's required. Here you can see in case of resource is null or it is not found from the database or some other service, we are throwing a custom exception with a message resource not found with the ID. So this message will be helpful at the client end or a business scenario, right? So moving to the next question, that is question number 8. Give an example of Singelton design pattern and how to achieve and how to break it. So the Singelton design pattern is a creational design pattern that ensures a class has only one instance and provides a global point of access to the instance. There were 3 ways we can achieve it. Here on the screen I am showing the first method. So in this method we need to make a private and static variable to hold the single instance of the same class, and to prevent the instantiation through the constructor we need to make its default constructor as private constructor, and then we need to make a get method of that instance as a static method. So globally anyone can create an instance of this class only via through this getter method. So coming to the second method, in case of multi-threaded environment this might not work, so we need to tweak it little. So I will make that global accessible get instance method as synchronized. So at any time any thread is accessing this method, that is get instance method, then it will make a check. If the instance is null, then only it will instantiate. And there is also one more way we can define a Singelton class, that is using the static inner class. This is also called build-bug Singelton implementation. So here in this case, instead of the static instance variable, we'll have a static inner class, and inside this static inner class we will define our instance of the outer class. So this kind of instance or the Singelton instance will be loaded only when the class is loaded, so that is only once, right? So with this also we are avoiding to create an instance through the constructor, right? So moving out to the next question, can you write a immutable class? So the immutable class is something once you instantiate it, you cannot change the content of it. Okay, this is also comes under the creational design pattern. So the class to be immutable, there will be no setters to prevent modification of object state. And one more important note is, if any of the fields are mutable objects, you need to return a copy of those objects to prevent them from being modified outside of this class. So here what it means that instead of the string here, if you have any other object type, that is custom object type in your immutable class, then every time you have to return a copy of that object so that original object content cannot be modified. And moving to the last question, the question is, what is anonymous class and why is it required? So the anonymous class is something which will not have a name. It is declared and instantiated at the same time. It is also often used to create a subclass of any existing class or to implement an interface without having to explicitly declare. For example, suppose the use of that class is very limited. In that case, we can declare that class as a anonymous class. Actually, it improves the code readability, also reduces the lines of code. Here in this example, you can see we have implemented the runnable interface, but there is no name for that class. And in this anonymous class, we have overridden the run method and written a custom message, right? And also we can call this our implemented run method using thread, right? By passing that instantiation variable to the thread, and we can call the start method as usual. So that is all about in this episode. Hope this is very helpful. We'll see you in the next. Thank you.